Okay, this is Mr. Ash for Chem 121, and I'm going to go through an example of one of these problems that I assigned for Module 3 on calculating the atomic composition of different molecules. And so I'm going to run through an example, not one on the homework set, but a similar one. And what I'm going to work through is trinitrotoluene here, which has the imperial formula C7H5N3O6. If anybody cares, this is what trinitrotoluene looks like. It's a benzene ring. So this aromatic structure here, it's got a CH3, one nitro group here, a hydrogen here, a second nitro group here, hydrogen there, and then third nitro group here. Right? So there's toluene and then 3 nitro groups. So that's trinitrotoluene. And what you're asked to do is calculate the percent composition of each type of atom in trinitrotoluene. And so the first thing you need is you need to know the total molecular mass of TNT here. And we could do that one of two ways. One is we could just look it up and it's 227.132, and this came off Wikipedia. So you can look things up if you want. The other way to do it is to calculate it. And so we know that carbon, its atomic mass is 12.001 grams per mole. Hydrogen is 1.008. Nitrogen is 14.007. And oxygen is 15.998. So we can calculate the mass of each one of these things, and then add them up. And that'll actually help us to get to the final step. So we're going to do it that way. And then we can check our work after we've looked it up. So there's 7 carbon atoms. So that means the total mass of carbon inside the TNT molecule is 7 times 12.011, because each carbon atom is adding 12.001 grams per mole. So 7 times 12.001 is equal to 84.077 grams. And then there are 5 hydrogens. So it's 5 times 1.008, which is 5.040 grams per mole. And there are 3 nitrogens. So it's 3 times 14.007, which is going to equal 84. No, I'm sorry. 3 times is 42.021 grams per mole. And then there are 6 times 15.998, which is 6 times 12 is going to be 95.988, I think, grams per mole. 6 enter 15.998 is 95.988, yeah, grams per mole. So if I sum all of these 4 numbers up, so 95.998, 42.021, and then 5.040, and then 84.077, and I get 227.126 grams per mole, which is pretty close to what was on Wikipedia. And so the difference here is there's some round off errors in each of these masses, and it's contributing a little bit. So this is close enough for 227.126 grams per mole. And so we'll take that as our molecular mass of TNT. You could use the value for Wikipedia. It doesn't really matter at this point. You'll get pretty much the same answer. So now to calculate the percent mass of each compound in TNT, what we're going to do is we're going to take the total mass of that particular atom in TNT and divide it by the total mass of TNT. So for carbon, the percentage of carbon in TNT is going to be equal to 84.077 divided by 227.126. And we have to multiply that by 100 to get a percentage. And so 84.077, oops, 077. And so that is 37.02% carbon. And so the percentage of hydrogen is equal to 100 times 5.040 divided by 227.126, which is equal to 5.040 227.126 is 2.1, I'm sorry, 2.2. 2.22% hydrogen, percent nitrogen is equal to 100 times 42.021 over 227.126. So 42.021, 227.126. And this is 18.50% nitrogen, and oxygen, percent oxygen, I'll just write that down, it's the same way. So it's 95.988, 95.988 over 227.6 times 100 is 42.26% nitrogen. And see what I've done here is I've carried each of them out to 2 decimal places because I'm going to be adding them up. And so this number here is fixing by our significant digits, is fixing the overall precision, which is why I don't extend this out one more, because I'm going to be adding all these numbers up. So if I add all these numbers up, 42.26, this is a good way to check your data. Check, make sure you did it wrong. I mean, did it right. And if you add them all up, you better get it come out to be 1, and it does. So this all, if I add these all up, I come out to 100%. So this is the percent composition by atom. Whoops, that's not oxygen. It's not nitrogen, that is oxygen. Sorry, oxygen there. And that's how I do it. So you just calculate the mass of each atom in the molecule and then divide it by the total mass. So some of the ones I've given you, for example, caffeine have got atoms in there, or isoflurane, but you'll do it the exact same way. Isoflurane, for example, which is C3H2 chlorine F5O. So you're going to have 3 carbons, 2 hydrogens, 1 chlorine, 5 fluorines, and 1 oxygen. And you calculate the total mass of that. Chlorine is 35.5. I just have to remember that off the top of my head. Carbon we've seen is 2.011, right? And just figure them out and add them up, and then divide and multiply by 100. Okay, so that's how you do that set of calculations, and you should find it's a little bit tedious once you figure out how to do it, but it's relatively straightforward. Okay, so that's all I got, and I will talk to you later.